So in this case, we are going to have a continuation from what we had previously, working with the proof of our identities. So we are given to prove the identities on this activity that we have. So we're not going to waste much time, guys. We still have our continuation. Remember, I referred from our previous class that we need to understand the identity from the tan of x, which is the sine of x over cos of x. So you can use the theta to represent where x is. And also from the Pythagorean identity that the sine squared of x plus the cos squared of x is equal to 1. And we saw that we can change the subject cos, which is equal to 1 minus sine squared, or we can change sine to be the subject. So it will be 1 minus what? Cos squared of x. So this is simply from this identity that we have. We're going to create these two from there. So it's just one identity there. So number one, we're given to prove. So it is either we work with the left-hand side or we work with the right-hand side. As you can see in our situation of this question, it is equally the same working from the left-hand side or working from the right-hand side. It is equally the same. It is equally the same, meaning to say we can work from whatever side that we need. Is it the left-hand side or the right-hand side in this case? All right. If we are to choose the left-hand side, this is what we have on our question number one. So on the left-hand side, we have got the cos of x, everything over 1 minus sine of x. So these are more complicated questions than what we had previously. We can see from this part that we do not even have the tan that we can say it is going to be the sine of x over the cos of x. We do not even have that. We do not even have a cos squared or a sine squared. So looking into this part, let's check the denominator. There is 1 minus sine x. So once you see this condition, guys, whether it is 1 plus sine of x, it is 1 minus sine of x, it is 1 plus cos of x, it is 1 minus cos of x. When you see this in the denominator or you see it in the numerator, on a condition that you can't even use the tan, any other identity, this is what you do. You introduce a negative to these identities. It is 1 plus sine x. So you introduce a negative as a product so that you have got a difference of two squares. So it will be 1 minus the sine of x. Remember the concept of a difference of two squares. A minus b into a plus b is equal to a squared minus b squared. So we know if there is an addition, another one is going to carry a subtraction. So if it is a condition like this one where there's a subtraction, it means what you're going to multiply with is going to carry a positive. So it will be 1 plus cos x. This one is 1 plus cos x. What we're going to multiply with is going to carry a negative 1 minus the cos of x. This is the condition. You make it to be a difference of two squares, different signs, a minus, a plus, a plus, a minus, a plus, a minus. Once you apply this, you can work out further from there because it is going to give you a squared minus b squared. So this is the condition of our question. In the denominator, we've got this part, 1 minus sine x. So if we've got 1 minus sine x, what are we going to use? We introduce a negative. We make it to be a positive like this one, negative, positive. So it's going to be 1 plus the sine of x, a difference of two squares. So remember this, guys. Remember this. So we're going to multiply because we are introducing something which is not part of our question. So if we introduce it initially to say it's going to multiply this part only, it means it is wrong because we are introducing this. So it is supposed to be affecting both the numerator and the denominator at the same time. So you're going to multiply by 1 plus the sine of x over what? 1 plus the sine of x, both the numerator and the denominator, so that it looks like you multiplied by 1. Look what's going to happen. If you cancel, it's going to be like a 1. Meaning to say you've got the original question as it is. There is no effect to this question. There's no effect. This is same as 1, this one. But if we just choose to multiply by this one only, you have affected your question. Or maybe you just choose to multiply the denominator only. You have changed the idea of the question. So you're supposed to have both on top and down in the denominator, just like that. So like I said, we are targeting to have a difference of 2 squares. So meaning to say the numerator, we are going to expand as it is. The cosine of x will expand this bracket. Do not cancel. You expand everything by the cos of x. So meaning to say, we are going to have the cos of x times 1, which is the cos of x. The cos of x times the sine of x, that is the cos of x, sine of x. Everything over what? Our difference of 2 squares, a squared minus b squared. So it's going to be what? 1 squared minus sine x squared. Difference of 2 squares, 1 squared minus like a squared minus b squared. So 1 squared, that is 1 minus sine squared. This one is just same as what? Sine squared of x, like this. This is what we have. This is where we are. So let's look into our question. Remember what we need. We need 1 plus sine x over cos. So as you can see, our denominator, there is cos. There is nothing about sine. The numerator, there is sine. So if we check, we have a cos in the numerator. We must get rid of that. In the denominator, we have a sine. We must get rid of that. So what are we going to do? Remember that identity, 1 minus sine squared, this one where we made the subject 1 minus sine squared from what? From cos squared. So it's going to be replaced with what? With a cos squared. So the denominator, we are going to have what? A cos squared of x. What about the numerator? There's something common here. A cos of x, there's also a cos of x, because these are two terms that you're considering. So you can factor out the cos of x, which is common. Same exponent here. So it's just going to take as it is the cos of x into what? Cos of x divided by cos of x. That's a 1 plus the cos of x, and cos of x was going to cancel. You remain with what? You remain with the sine of x. This is what we have. Remember what I said before. Cos squared means that there are 2 of them. So we can cancel 1, this one. Cos into cos, that is 1. Into cos squared, remember there are 2. So if you cancel here, we are going to remain with 1 cos x. 1 is going to remain. There are 2 like this. Cos of x times cos of x over what? Like this one. 1 is going to cancel. So you remain with 1. This is our condition. All right. So that is our condition that we have. And as we can see, this is exactly what we have in the numerator. On the right-hand side of our equation, everything that we are left with, this is cos of x. 1 plus sine x over cos x. 1 plus sine x over cos of x, just like that. Exactly as we have it on the right-hand side. This is exactly as we have it on the right-hand side. Just like that. So guys, you see these questions, it's all about revision. So meaning to say, in the same way, I could have applied it from the right-hand side, because as we can see, our question, it is equivalent. It is like equally the same, guys. Working from the right-hand side or working from the left-hand side, it was just like equally the same. Let's see from the right-hand side, 1 plus sine of 1 plus sine of x over, let's just have it here. 1 plus, from the right-hand side, we're going to start with the right-hand side. 1 plus the sine of x, everything over what? The cos of x. So we have that condition, just like the previous part, the 1 plus sine, but it is in the what? In the numerator. So we said we need this condition of a difference of 2 squares. So it is 1 plus sine. What are you going to use? 1 minus sine of x to introduce a negative. It was positive. The other one going to carry a negative over what? 1 minus the sine of x. This is where we are. A difference of 2 squares from where? From the numerator. We are going to have it. All right. Remember our difference of 2 squares. 1 squared minus what? Sine of x squared. So it's going to be 1 minus sine squared of x over what? This part we have to expand the denominator. Expand by the cos of x. All right. Going to expand. So meaning to say, if we are to multiply this, what are you going to have? Cos of x times 1. That is the cos of x. Or just leave it like that. Leave it. Why are we going to leave it? Look at our answer. Remember, I'm still thinking that we are from the left-hand side. Remember, we are from the right-hand side. I want you to see what is on your answer. Your answer, there is 1 minus sine x in the denominator. So leave that part here because we need this 1 minus sine x on our answer. So guys, like I said, proving, you're also looking into the question. So leave that. So just multiply like this. Cos of x, open the bracket. 1 minus what? 1 minus the sine of x. Leave it like that. Do not expand the brackets, all right? Because we need it here. We need it here. 1 minus sine x. But if you check, there's a cos of x in the numerator. There's a cos of x. But in our numerator, there's what? There's a sine squared. So what can we do? We are back to that identity again. 1 minus sine squared. It was taken from where? Let's go back here. 1 minus sine squared from where? From cos squared. So we are going to have it as the cos squared of x. On top, we are going to have it as what? Cos squared of x. In place of this, everything over what? The cos of x into what? 1 minus the sine of x. So just like the previous case, the cos of x into this one, there are 2 of them. So if you cancel, we're going to remain with 1 cos there, which is on top. So that is the idea of our question. We could have worked it from the right-hand side. So from the numerator, we are going to remain with the cos of x. What about the denominator? 1 minus the sine of x, just like that. So that's cos x over 1 minus sine x, exactly what we have on the left-hand side. So we proved from where? From the right-hand side to say it is the same as the left-hand side. That is the case. So in this condition of our question, we can work from either side. Well, the left-hand side is up to you. The right-hand side is up to you. Let's look into question number 2, another complicated, but the more complicated part there is on the left-hand side, guys. If you check properly, it is best that we work from the left-hand side. So number 2, I'm going to choose the left-hand side where I have got the cos squared of x minus the cos of x minus the sine squared of x. Everything over what? This is 2 sine of x times the cos of x plus the sine of x. So it is supposed to give us this 1 over tan x minus 1 over sine x. All right, no problem. Let's figure out. So take note, there we do not have a 1 on the cos squared minus. Take note, it's minus. It's not a plus. Where we have a 1, it's supposed to be what? A plus. So let's figure out what can we do in this question. It is either, because we can, if we look properly, I want you to see something here. If you look properly here, there is a cos and there's also a cos, right? We want to study our question. But here there's a sine. There's nothing that we can do. We do not have like a condition like the previous case, guys, where we can say sine squared x plus what? Cos squared of x is equal to 1. That part does not work. So what we can do is to get rid of the sine, this one, so that it, this one, the sine squared. Let's get rid of this. Let's rewrite it in terms of what? In terms of a cos. Because we already have a cos here, we already have a cos there. So remember, sine squared in terms of a cos is what? Sine squared. It's 1 minus cos squared. Sine squared is what? 1 minus cos squared. So let's put that one. 1 minus what? Cos squared. Let's see what's going to happen here. So we are going to have the cos squared of x minus the cos of x. Minus, remember, in place of what? Of sine squared. We are going to have 1 minus cos squared of x. This is what we have. Everything over what? In the denominator, we can see that there is something common here. The sine of x, we also have the sine of x here. So meaning to say we can factor out the sine of x in the denominator. It is common. There are two terms. This one is a single term. This one is a single term. So you can factor out this sine of x. It is common. As we are simplifying, let us factor out. Factoring out sine of x, you're going to remain with what? 2 cos x. So you remain with the 2 cos x plus what? If you remove this one, what are you remaining with? That's a 1, just like you have a 1 there. So this is what you have. All right. So this is it, guys. We managed to bring the cos in the in the numerator here. We now have everything in terms of cos. The denominator, we factorized. So what can we do now? Let's look into our question further. Let's simplify. Expansion of brackets, collecting like terms from the numerator. So this is cos squared of x minus cos of x. So we're going to expand this bracket here, 1 minus cos squared of x. What is going to expand this bracket? The number outside of the bracket, meaning to say there's what? A negative there, negative 1. So it's negative 1 times 1, which is negative 1. Negative 1 times negative, that will be positive cos squared of x. Everything over what? Remember our denominator. We factorized this. It's 2 cos of x plus 1. Like this. This is what we have. This is where we are. In the numerator, we've got like terms. In terms of the cos squared, there's cos squared here. There's also a cos squared. So let's add these two. 1 plus 1, that's 2. So it was going to give us 2 cos squared of x minus the cos of x minus 1. Everything over what? This is the sine of x into what? 2 cos of x plus 1 like this. This is where you are. So guys, trigonometry part and algebra, they do work hand in hand. Hand in hand. As you do understand your factorization, it means we can see the quadratic part there. We can do factorization. Cos squared here, cos squared is just like you introduce to say, let the cos of x be equal to k. So meaning to say here we are going to have what? 2k squared minus what? Minus k minus 1. If you understand that way, you factorize this. You factorize. Guys, you know your factorization the same way that you're doing your factorization using the concept of the still method that I explained. 2 times negative 1 is going to be what? Negative 2. So we are going to have k squared minus k minus 2. Then factorize, guys. The part of factorization here, just do your normal way, the way that you are used to factorization. The coefficient of k squared is 1. So we're going to have k here and k. Then considering the factors of what? Of negative 2, which will give us what? A negative 1. In this case, we've got negative 1. So negative 2, that's negative 2 and what? 1. If you multiply this, you get negative 2. If you add, you get a negative 1. So that's negative 2 and a positive 1. You bring back the 2 here that you stole. So you must bring back where the k is. So where you see the k, you bring back that 2, then factorize where applicable. First bracket, 2 is common. We're going to factor out 2k to 2, that's k, minus 2 and 1, that's minus 1. Into what? The second bracket, nothing is common. Remember, this is 2 here. Here is 2. So it's going to remain as it is 2k plus what? 2k plus 1 as it is. There's nothing that is common. So the 2 that we factored out becomes useless in using this method of the still method, cheat method. Guys, the factorization is in your hands. How to factorize there? I want you to do it the way that you understand, the way that you have been taught. But what is important is that you're going to have two brackets. And remember, our K represents what? The cos of X. So you're going to write this one as the cos of X minus 1 into what? 2K, which is 2 cos of X plus 1. Everything over what? Our denominator, which is the sine of X into 2 cos of X plus 1. Remember, this one is already in the simplest form, our denominator. So we just have to leave it like that. As we have factorized our numerator, we can see that there's something common between the numerator and the denominator. This bracket and this bracket can cancel. So meaning to say, you are going to remain with what? With the cosine of X minus 1 over what? Over the sine of X. Is it what we are given to prove? Is it what we are given to prove here? No. They said we are supposed to get 1 over tan minus 1 over sine. So the question is, how can we get this now? 1 over tan minus 1 over sine. Because in our case, we are telling ourselves that now I have simplified. You are in exam. It's just like you're in exam, guys. You are in an exam condition. This is what I was telling you to say. Questions, when they are like simplify, you can leave your answer here because you're telling yourself, I'm done here. You're done. But this one, you cannot leave your answer here because they say to prove there is a certain answer that you're supposed to show. So we are supposed to rewrite in that format what happened for us to obtain that part that we are given of 1 over, they said 1 over tan X minus 1 over sine X. What happened? Let's separate. As you can see, sine of X is the denominator. So we can separate. It means cos of X over what? Over sine of X. When I have cos of X over the sine of X minus 1 over what? Sine of X. This is what it means. Remember, I told you guys, if you know that tan of X is sine over cos, therefore know that if you are talking about 1 over tan, if you're talking about 1 over tan, which is our cot of X from our grade 10. But here we just want to write in terms of this sine and cos. So 1 over tan is simply means interchanging the reciprocal. So it will be cos of X over what? Over sine of X. So once you see this, know that it's 1 over tan. So we have got cos over sine. As we are used to what? Sine over cos. We know that sine over cos is what? Sine over cos is tan. So once we see cos over sine is what? 1 over tan. So this is what we have there. So it was going to give us 1 over the tan of X minus 1 over the sine of X. Exactly what we were given on the right-hand side. You are being given to prove. You don't just answer the way that you want at the end. Okay, you underline here because you are done. You're saying, I'm done. No. There is an answer. There's a certain answer that you're supposed to show. Can you show that? That is the question of proof. It's just like what? It is just like proof. It's just like show that. Show that the answer can be written like this. So you're supposed to think along the lines of what? The examiner. What was the examiner thinking at that moment? You have to think along the mind of the examiner in exam. All right. Number 3, we can see also, the left-hand side is complicated. So let's work with the left-hand side. So that is, the left-hand side is sine of X minus 1 over what? The sine of X plus cos X. All right, that's an interesting question, this one, plus the cos of X. So as we can see, guys, it will be like there's nothing that we can do like in our simplification. This is what you're supposed to have, a single fraction. As we can see, we've got what? A single fraction. So like I'm saying, guys, looking into this question, it will be like there is nothing actually that we can do looking into this question. It will be like there's nothing that we can do. But let's just add. What if we just combine? Because this is a fraction. Sine of x is same as what? Sine of x over 1. Cos of x over 1. Add, combine everything. What is the LCD or LCM of these denominators? 1, sine x plus cos x, and 1. So it's going to be this one. All right, because this is 1, this is 1, guys. So we're going to just take what? Sine of x plus cos of x. Remember your division. You divide this one to 1. It is going to remain as it is. Then you multiply to what? To sine of x. So it was going to be sine of x into, remember, this is what we got here. Right, sorry. The sine of x plus what? Cos of x, it remains as it is when you divide to 1. All right, plus, sorry, that's a minus here, minus, that's a minus. So this one divided to this, what are we going to have? It will cancel this one. They will cancel to give us a 1. So it will be 1 times 1. So that's 1 times what? 1. Plus the same thing, this one divided to 1. It will remain as it is, but multiplied what? To cos of x. So it will be cos of x into what? The sine of x plus cos of x, just like the previous case here as it is. Expand the brackets and see what you're going to have. Lucky enough, we can see that the sine of x plus cos of x, this one, sine of x plus cos of x is already there. We already have it in the denominator, sine of x plus cos x. So it's all about simplifying the numerator. The denominator is already what we want. So we are going to leave it like that. So let's go to the numerator, guys, expanding of brackets. Sine of x plus cos x. We also have here sine of x plus what? Cos of x. What is expanding our brackets? First part is sine. So meaning to say it's sine times sine, which is what? Sine squared. That is sine squared of x. Then you move on, sine times cos here. It is going to be plus the sine of x cos of x. Sine times cos. Minus 1 times 1, that is minus 1. So this is where you are. Expand this bracket by the sine, the cos of x, it's a positive, this one. So that's positive cos x times the sine of x. It is going to be cos sine. So you're going to have plus. So take note, guys, it was going to be like this. Cos of x, sine of x. But look how you wrote here. Sine x, cos x. Write it in the same way. There's nothing that has changed. AB is equal to BA, remember. So you can write it as what? Sine x, cos x, so that you avoid confusion, seeing as if these two, they are different. No, they are not different. The moment you write it like this, you might be tempted to leave that part because you're saying it's different. But if you see it like this, properly written in the same way, sine to a sine, cos to a cos, you will never miss that part, guys. You know, these are like terms. All right. You do the same thing, the cos to the what? To the cos. So that's cos times cos, which is what? Cos squared. Cos times cos is going to give us cos squared of x. Everything over what? Our denominator as it is, the sine of x plus the cos of x. As it is. Our identities can be used. Remember that once we see a sine squared and a cos squared, guys, that part we are not supposed to look aside for anything. Once you see this sine squared plus cos squared, you know that it's a 1. It's positive, it's positive. Sine squared plus cos squared is what? It's 1. So that was going to give us a 1. All right, we've got like terms here. Let's consider the like terms. This is 1 sine x, 1 sine x. 1 sine x cos x, we're going to add 1 plus 1, which is 2. So that will be 2 sine of x cos of x. There is a minus 1 here originally on our question. So put it there. That is over what? The sine of x plus the cos of x. So these we're going to cancel 1 minus 1. That's what? That's a 0. So you're going to have what at the end? You're going to remain with this part as it is 2 sine of x cos of x, everything over what? Over sine of x plus cos of x. This is exactly what we were given on the right-hand side. Is it exactly what we were given on the right-hand side? Let's look again. Let's look again, and see. Guys, proving. If you are proving, guys, you have to be careful. 2 sine x cos x over. So this is it. 2 sine x times cos x over this. This is it. We are done. There's nothing that we can do. There's nothing that we can do. We are done. This is our right-hand side. Okay, so you can just write this is equal to the what? Right-hand side. So that is it, guys. That is it. See these steps. Follow the steps. It's not that much, guys. It's not even that much. It's not even that much. It's only that your grade 11 mathematics, you must know all the basics, guys. This is the stage where your grade 10 must be very, very firm. You must be very, very firm in your grade 10 mathematics. Very, very, very strong. That can help you a lot. Question number 4. We are supposed to obtain this. All right. Let's work with the left-hand side again. So this is what we have. The sine squared of x plus the sine of x minus the cos squared. This one is just like a repetition of what we had on this question. I want you to see this one is just a repetition, guys, of this question, the first one. You look the second one. If you check the second question that we had, you still remember here, where we had to write one in terms of another one, sine in terms of a cos, then factorization. It is the same thing with this one. We can see that there is a sine, there's a cos in the denominator. So this is sine, this is sine. So we're going to change this cos into a sine. This is the only cos that we have. So that is why we have to change it to a sine. So that was going to give us what? Sine squared of x plus the sine of x minus, we change our cos to a sine, knowing that the cos squared of x is equal to what? 1 minus sine squared. So we're going to substitute this with 1 minus the sine squared of x. Everything over our denominator, which can be factorized. Just like the previous case, we can see that sine of x, the cos here, the cos of x and cos of x is common. So let's factor it out. What are we going to have? If we factor out the cos of x, removing this cos of x, we are going to remain with what? 2 sine x minus cos of x divided by cos of x, that's a -1. So this is what you're going to have. And we can expand the numerator, expand brackets, collect like terms, and see what's going to happen there. This is going to be sine squared of x plus the sine of x. What is going to be used for the expansion of this bracket is the number which is outside of the bracket, which is what? The -1. So that's simply -1 times 1, which is what? -1. We move on, -1 times a negative, negative, that's what? A positive. So this is positive sine squared x. Everything over what? Our denominator as it is, which is the cos of x into what? 2 sine x. All right, so this is 2 sine x minus 1. This is where we are. This is just a previous question, guys. Here, guys, this is such a previous question. You end up factorizing this and that. This is just our previous question, guys. The way that we had it before that time. So you're gonna add this one and this one, 1 plus 1 here, which is what? 2. So it's gonna give us 2 sine squared of x plus the sine of x minus 1 over what? The cos of x into 2 sine of x minus 1, like this. Just like the previous case, guys, we end up with the factorization as we had, like I said, you can even introduce k in place of sign to say, let k represent the sign of x. So it's going to be what? 2k squared plus k minus 1. You factorize, guys. So this is your factorization, guys. Can you just factorize the way that you understand? You're going to have k here, minus 2, no, positive 2, and negative 1. Is that so? Then we bring back our 2 in place of k, factorize where possible. The first bracket, 2 can be factored out. We remain with k plus 1. All right, the second bracket, nothing is common. So it's going to be like this, where k represents what? Sine of x. So it means you're going to have a bracket with sine of x plus 1 into what? 2k, where k is the sine of x. So it's 2 sine of x minus 1. As long as you have these brackets, guys, we are on them. You're in the right direction. Your factorization is valid. Your factorization is what? Is valid. Use it in as much as you can. That means you understand that part. Use the way that you understand, guys. All right? Your factorization. I might have my own way. You might have your own way. But these brackets at the end are supposed to be exactly the same. So what can we do? The numerator to the what? The denominator. This part and this part exactly the same. So that was going to give us sine of x plus 1 times 1. That is the sine of x plus 1 over what? Cos of x times 1. That is the cos of x. At this stage, guys, we are done simplifying. But is it the way that it is given on our answer? Because we are done. We are now to check to say, is it the one? Yes, we can see this is exactly the one. Sine of x plus 1 over what? Over cos of x. So this is what we have. Sine of x plus 1 over what? Cos of x. Exactly our right-hand side. So this is like an extended part of your trigonometry. An extended part, especially under exam. They can extend their question to be their questions to be like this. So do revise as much as you can. We are going to meet in our next class working with the reduction formula, knowing the concept of our reduction formula, concept of angles, positive and negative angles. So make sure that you do not miss that part. Just follow up the classes in the playlist for our trigonometry for term 1. You follow that that can help you to follow up the classes from from the first one up to the last one, and also the question papers. So that is it, guys, from Mason African Motives. Till we meet again.